right, we're live? Okay, great. Welcome, everybody. So this talk is going to be about where the Java language is going, and you'll notice the subtitle, late 2019 edition. I've adopted the Apple, version numbering scheme because this is a topic that is a moving target. We're delivering rapidly, we're innovating rapidly, so what I might speak about in a talk with the same title earlier in the year might not be the same content later in the year. So this is to prove that I work at Oracle. So you've all seen that, now you believe me. Okay, so Java has been around for a long time, almost 25 years. And it seems to be a hobby to periodically declare Java to be dead. And if it's a popular hobby, I can understand that, but my job is to confound those beliefs. And so 20, 25 years later, Java is still the world's most popular programming platform by some measures. And we want that to continue to be the case for a long time going forward. And our super, super secret plan for doing that is to stay relevant. Okay, big secret. Stay relevant to the problems people want to solve. Stay relevant to the hardware people want to run on. Keep the promises we made to our users by having code that they wrote 5, 10, 15, 20 years ago still work, so that we don't invalidate the investment people have made in their code. So we talk about this in terms of keeping our promises. We've made these implicit promises that Java will remain largely the same Java, even though it evolves. And that means code you wrote 20 years ago should just continue to work. And we think that this is really the secret to Java's success, is that the investment people have made in writing Java code, in learning how to program in Java, is not an investment that depreciates rapidly, because things you did, things you learned 5, 10, 15, 20 years ago are still useful. And this has a cost. Evolving with compatibility has a cost. It means things happen more slowly than they might otherwise happen if we were willing to move fast and break things. A good example of that is how did we do generics, right? Generics were originally scheduled for Java 1.3, then 1.4, and then 5. And it was a long time coming. And the reason it was a long time coming is that we were trying to figure out how to do it in a migration-compatible way so that existing code would still run after, say, a library was generified, and that code would have the choice to migrate gradually. It could migrate immediately, later, or never, as it saw fit, and have there be graceful degradation at the boundaries with no flag days. This is like 80% of the work, and this is why evolving Java takes longer than evolving other languages, because we're trying not to invalidate your investment in existing code. And if we do this right, we get a sort of nice bonus, like we did with lambdas. So Java made the choice to do lambdas using nominal function types, functional interfaces, instead of structural function types. And a lot of people looked at that and said, you guys are crazy. The obvious way to do it is to put structural function types in the language. And that would have been a reasonable way to do it if we were starting from a clean sheet of paper. But one of the reasons we did it this way is it meant that we weren't disrupting the way Java developers think about APIs. And in fact, 20-year-old APIs that had no idea lambdas were coming in 20 years could work with lambdas on day one without recompilation, because they worked with abstractions like runnable and comparator and things like that. So the compatibility is very important to us, especially migration compatibility. It has a cost, but it has a big benefit. Another reason, I'm getting through all the reasons why Java moves slowly. We'll get them out of the way first, and then we'll talk about the things that Java is doing. Another reason why you might perceive Java to move slowly is we're very aware that we're working on a long time scale, and language features are forever. Any language feature we put in the language today is going to be there for a long time. We're going to have to support it for a long time, and it's going to be interacting with every other feature that's in the language, past, present, and future. And so the cost of making a mistake means not only do we get it wrong and can't fix it, but it might be also that there's 10 other good things we can't do because it interacts badly with something that we've already done. And so the motivation there is, if you don't know what the right thing to do is, then the right thing is do nothing and wait until you do know what the right thing to do is. And I'll posit that generics were a prime example of that. I mean, it's not like we didn't know what parametric polymorphism was in 1995, and it's not that we didn't think it was important. We didn't know how to do it right. And if someone had said, Java 1.0 must have generics, well, we could have met that requirement, and we probably would have gotten something like C++ templates and how happy would we all be about that? So instead, we had to wait 10 years. That was awful. But we got a generic type system that made much more sense for Java than what we would have gotten in 1995. And as programmers, we obsess about language features because we look at code all day. But language features are a means to an end, and that end is making it easier to build and maintain reliable programs. That's really what it's about. Okay, so I keep talking about this in the context of evolution because I really think that that's what's going on. This is an ecosystem, and in that ecosystem, you can think of programming languages as being the predators and programming problems as being the food supply, and there's an environment that we all work in, computing hardware and the state of practices and fashions and all that. And in a real ecosystem, things change. And if the participants of that ecosystem don't evolve, they die out. And so programming tools that might have been ideal for solving the programming problems of one era may not be ideal for solving the programming problems of another era. And if they don't evolve, then they'll be replaced by something else. So we want to remain relevant. We want people to keep programming in Java. So we need to evolve Java to keep up with expectations, hardware, what people intend to do with their programming languages, and maybe even to some degree developer fashion. So we're clearly not done. We're never going to be done. We're going to continue to evolve, but we want to do it carefully so that we don't get ourselves into a situation where you can't cram anything else into this language. We've all seen languages that have suffered that fate. We're still waiting for Perl 6, right? Because Perl got full, and they couldn't figure out how to evolve it. Okay, so going over this very quickly because you heard about this at the keynote. About 2 years ago, we switched to a 6-month rapid release cadence. We've delivered 4 releases under that cadence. As compared to the old way of doing things, which were these 2 to 4 years, you hope it's 2, in reality it's closer to 4, feature-driven releases. And we're all familiar with what was wrong with the old model. It took a long time. It was difficult to accurately plan. The cost of missing the train was enormous. That meant we had a huge overhead of release management. Little features got stuck behind big ones. And the world has changed. Expectations have changed, and by moving faster, not only can we deliver value faster, but we can also let go of some of that crushing release management overhead and spend more of our energy on developing features. Java 9 was the last release under the old model, and since then, every 6 months, we've delivered a release. Java 10, 11, 12, 13 just went live today, and we're halfway through the development cycle for 14. And it's working great. It's really working great. And there's, as I said yesterday, there's useful features in every version. Not necessarily features from every category. There's not necessarily language features in every version. There might be runtime features or library features. And it kind of changes the way we have to look at the contents of a release, because we used to look at what's the big thing and then decide whether that was important to us. Now, there aren't going to be big things, because the big things are going to be broken down into smaller things, and we kind of have to look at the totality of, well, what are all the improvements we've seen in the last 6 months, a year, 2 years, et cetera. It's a little bit of a different way of looking at it, but I think it's a healthier way of looking at it. And language features, because they are special in the sense that they're almost impossible to change, unlike library features, which can be extended or deprecated, we're sort of taking an extra effort to get them right by having a mechanism which we call preview features. So a preview feature is a fully complete feature. It has a full implementation and specification, but it is sort of in provisional status for 6 to 12 months while we gather feedback. So in the event that we messed up, there is an opportunity for people to say, whoa, you didn't think about this particular case, and we can look at that feedback and act on it and decide whether we want to revise it based on feedback. And we think this is a positive thing. Might be a little bit frustrating that there's a feature that's like 99.9% done, but you can't use it in production yet. This is the cost of not making a mistake. And so we expect that all language features will go through at least one round of preview. So the best kind of feedback, the kind of feedback that we really hope to get from people, is telling us things that we didn't know, right? There's lots of people have opinions about what the syntax should be. We've heard all of those. And that's not necessarily particularly actionable feedback, because if different people have different opinions, you can't make them all happy. But telling us things that we didn't know, of the form, I tried it this way, and look at this strange behavior I got. That's the kind of feedback that we might actually act on and change a feature before it goes permanent. So to use preview features, you have to enable them explicitly so that, and the reason for this is what you don't want is someone using preview features in a library that they put in Maven Central, that's one of your indirect dependencies, and all of a sudden you have a dependency on a specific version of Java that you didn't realize you did. And so you have to be a little bit explicit to enable them at compile and runtime. And IntelliJ IDE has IDE support for preview features that if you go to the language level picker, and it'll say, you'll see 11, 12, 12 with preview, and it will it will adjust its view of the language depending on what you've selected. So we think this is a successful mechanism. It's the jury's still out. If it doesn't work, we will try something else. Okay, so let's actually talk about the language instead of meta language issues. In OpenJDK, we have a number of projects that have funny names, and they have rough categorizations. And Project Amber is the umbrella project for what we call right-sizing language ceremony. It's the smaller language features that that are aimed at developer productivity. They're not the big earth-shaking, change the platform kind of features like Valhalla is, but they're the features that a lot of developers care about. And Project Amber has already delivered local variable type inference in 10, switch expressions in 12, text blocks in 13, and there's a pretty rich pipeline of stuff that's coming. So even though 10 is old news, that's 3 releases ago, I suspect that some of you aren't on 10 yet. Who's not on 10 yet? You should all be ashamed. So it's new to you, so I can talk about it in my futures talk, even though it's way in the past for me. So you're all familiar with the fact that in order to declare a variable in Java, you have to give it an explicit type, and then you have the variable name, and then maybe you have an initializer. And sometimes this is helpful. Sometimes it makes it easier to tell what's going on. Sometimes it just gets in the way because the type name is redundant with the variable name or is obvious from the context, or the type name is this big, god-awful, abstract broker, provider, factory, locator system, and you just don't want to have to say that. And so what is local variable type inference about? It's about allowing you to request that the compiler infer the type of a local variable for you, strictly on the basis of what's the type of the initializer on the right-hand side. So Java has had type inference since Java 5. We had type inference for generic type variables. In 7, we added type inference for constructor type variables. In 8, we added inference for lambda formals. And so this is just another place that we're using type inference where you can be explicit or not be explicit. In some cases, writing it this way will make your code more readable because the most important thing in most lines of this form is the variable name. That's the place where the programmer actually used intelligence and creativity to say what they meant. And so that's kind of the thing that you'd like to be front and center in the reader's perspective. If it turns out that deleting the type it merely obfuscates what's going on, feel free to use an explicit type. This isn't a requirement to leave the types out. It's an option. And in a lot of cases, the program becomes more readable, or at least as readable as it was in the beginning, as long as you pick reasonable variable names, which we all do all the time, right? Right. So if you're interested in this topic, you can leave the room and go 2 rooms over and go to Stuart Marks's talk, who's doing a whole talk on this one slide. He's obviously getting into a lot more detail than I will. But I see you've chosen to stay here, so let's go forward. What are the rules? Okay, this is only for local variables. It's not for method return types or fields for reasons that I think should be obvious. A lot of people describe this as being syntactic sugar. That's actually an incorrect use of the term syntactic sugar. It's not syntactic at all. It's about type analysis. And the Java type system is a little more complicated than a lot of people give it credit for. So I'll show you a few examples of cases where the type of something isn't quite the type you think. So for example, supposing I have an instance of something called this class, so I say this.getClass, And what's the type of that? You might think it's class of question mark, but it's actually class of some capture type. Capture types are part of the Java type system. They have been since Java 5. Most of the time, they stay where we can't see them, which is how we like it. But they do, if you ask the compiler what's the type of the thing on the right-hand side, it will tell you accurately, and you may get a type that surprises you. Here's another example. List out of 1, 2, 3. Okay, you might think that the result would just be a list of question, or a list of question extends object, or something like that. But actually, integer and string have more in common than you think. They're both serializable, they're both comparable. So you're going to get a list of question extends, serializable, and comparable, where there's something in the type argument for comparable, which is actually question extends, serializable, and comparable, ... And so these types, so here we see a capture type, here we see an intersection type. These are types that are part of the type system. A lot of developers don't know about them. So this is a feature that is going to expose some of the dark corners of the type system to users where they might see them for the first time. And that's one of the trade-offs we make about allowing you to say, I'm going to let the compiler do this for me. The compiler might do it a little differently than you would have yourself. Sort of a funny meta issue about this feature is, so this was like the most commonly requested feature of like people who would stop me in the hallway as I walk in conferences and come up to me and say, I really want var. They may not know it's called local variable type inference, but they say, I really want var. Why can't I have var? Scala has var, Kotlin has var. And okay, after several years of hearing that over and over again, and being able now to work on smaller features instead of big features and big releases, we said, all right, maybe it is time for Java to adopt that. So we said, okay, we're going to do that. You guys happy? No, of course people weren't happy. Immediately, the other half of the community, who hadn't been saying anything, came out of the woodwork saying, oh, you're just giving into fashion. Oh, you're encouraging bad developers to write bad code. Like they need encouragement, right? And in the end, neither of these groups turned out to be right. By the time we actually shipped it, no one had anything to say about it. They had all moved on, right? So, it's a little bit of a cautionary tale to not take quite so seriously everybody's rantings about what will or won't happen if you do or don't make a certain change in the language. In reality, it's a language feature that enables us to maybe write better code, maybe write worse code, and as long as we're able to use our judgment, you all have that, right? Then it'll be fine. And Stuart wrote a lovely style guide and FAQ about the feature. They're up on the OpenJDK website about what's this feature for, why did we do it, when would be good places to use it, when would be bad places to use it, what would be things I should think about when considering using it, which I think are, should be helpful in using this feature effectively. Okay, so let's move on to what we did in Java 12, switch expressions. A lot of switch, so switch can only be a statement currently, not an expression. And that's a little unfortunate because it turns out if you look at real-world switch statements, most of them are actually simulating expressions in a somewhat roundabout way. And switch, everyone loves to beat up on switch. It was probably one of the weaker features in Java 1.0, in part because I think it was copied a little too literally from C. And so, for example, the default is to fall through rather than not to fall through. So if you want to not fall through, you have to say break, which you have to say 99.9% of the time. And so we had already been looking at enhancements to switch as part of pattern matching, which I'll talk about in a bit, and switch expressions sort of dropped out naturally. So here's an example of a switch where we're simulating an expression. We're doing some multi-way conditional, and in each arm we're going to stuff some value in a local variable, and then we're going to go on and use it. And there's a lot of verbosity here. There's a number of places to make mistakes. If you forget to break, then you have a subtle bug. And then to add insult to injury, even though we're switching over an enum and we've covered all the days of the enum, we still have to have a default clause that says, I don't know what happened. And so, it's not surprising why people, like to hate on switch. And so we have this redundancy, and we have the redundancy of the breaks, and then we have that. Here, I've rewritten it as a switch expression. It's gotten a lot more compact, that's nice, but more importantly, it's gotten less error prone because as an expression, you expect to see exactly one expression on the right side of that arrow, so I don't have to say break. And because I'm switching over an enum and the compiler has validated that I've covered all the cases of the enum, I don't need a default. The compiler does generate a default clause for me in the event that somebody adds a date of the week between compilation and runtime. But in general, this is a lot closer to the code that we probably had in mind when we sat down to write this. So that went into 12 as a preview feature. We made some small modifications to it, and it re-previewed in 13, and we fully expect that it will be a permanent feature in 14. This is actually two separate enhancements to switch that are orthogonal. One is switch can now be either a statement or an expression, and the other is the new form of switch labels where previously it was case something colon and then some statements, and the other form is case label arrow and then a single consequence. And in fact, you can mix and match these two things, and so you can use either form of label with either switch as an expression or statement. I expect most of the time people will choose the expression arrow quadrant of this 2x2 matrix. But we did it this way because we felt that by defining it as two simpler features that interacted nicely, it was simpler than having switch statements work this way and switch expressions work a totally different way. And so people call them switch expressions even though the feature is a little bit more complicated than that. In JDK 13, we did another feature that was kind of in the same category of things that people bug me in the hallways about, which is multi-line strings. This is another persistent pain point of I have some snippet of HTML or SQL or JSON that I want to have embedded in my Java source code, and it's more than one line, so I have to represent it as a concatenation, a bunch of strings with some \n's manually inserted, which is error prone and obfuscatory and makes it harder to read and easier to make a mistake. So wouldn't it be nice to be able to say what I mean? And it's not a particularly sophisticated feature, but that's okay. And so this is how we have to do it today. And so the yellow stuff is the stuff we would like to get rid of. And if I express this as a text block, it looks something like this, which is to say it's a string literal. It looks a lot like the old kind of string literals. You can use all the same escape sequences inside of it. It has a different delimiter, and it's allowed to span multiple lines. That's the difference. And this is easier to read. It's also easier to write. You can just cut and paste your HTML code directly in. And switching from a single line format to a multi-line format brings up the question of, what about this stuff? I indented my code because I wanted it to be pretty and readable, and that's a good thing. On the other hand, now there's a bunch of extra spaces in between my delimiters. Are those part of my string or not? There was a lot of debate when we were designing this feature about how to do that. And we eventually settled on a heuristic that allows the compiler to decide which space is incidental, in other words, which has been inserted purely for the purpose of aligning the text literal with the code, and which space is essential. And so the spaces corresponding to the dots would not actually appear in the output of the string. And you're probably thinking about 17 different what about cases in the back of your head. And yes, those are all valid, and yes, within the rules of the heuristics that we've defined, they can all be expressed by changing the positions of the delimiters. And this was an interesting feature to design because we looked at what other languages do. And very often when you look at what other languages do in a particular area, you see 2 or 3 clusters of, well, these 6 languages do this thing this way, and these 4 languages have chosen this other way. We looked at multi-line and raw strings in 15 languages and found 15 different ways to do it. So, of course, what did we do? You got it. For good reasons, but it was very clear that subjectiveness was an essential part of the design process for all of the feature in every language, where the designer clearly had an intended use case in mind and optimized the feature for that case. And that's allowed. There isn't, I mean, if we saw 15 other languages all did it the same way, that would be reasonable evidence that there might be a reason to do it that way. When you see everybody's done it a different way, that's kind of reasonable evidence that there may not be one right answer. And so we chose a answer. Okay, so let's talk about what's coming soon. Um, You've all been through the pain of declaring domain objects, by which is modeling data with classes, and it's well understood how to do this. You read effective Java; it tells you exactly what to do. But oh my God, is it tedious, right? Constructors and accessors and equals and hash code and toString, and this is bad for a couple reasons. One is it's annoying to write, but that's actually not the important reason. It's annoying to read. You have to read a lot of low-value code to validate that you didn't need to read that code. So that's kind of wasting the reader's time. We don't like that. And it's error prone. It's really easy to make a cut and paste error when doing this. And so we felt that it was important to have a way to say a class is just a container for its data. And this is actually a trick, this embodies a trick that we did in Java 5 with enums, where an enum is kind of this deal between the compiler and the programmer, where the programmer says, I'm willing to give up something. I'm willing to give up control over instances. And the compiler can say, okay, well, if you're willing to let me manage the instances, then I can deal with the details of instance creation and equals and construction and all of that for you. So records are a kind of similar deal, where the programmer says, this is just a dumb class. The API should be derived strictly from the data description. And in return, the compiler can fill in the boilerplate because you've told it what to do. Okay? So, we'd like to write this. We can't write that. We have to write this. And all of that small type code is, I would call it negative value code. It gets in the way. It has to be read. You can get it wrong. It's a place to make mistakes. And a record is a class. It's not something special and different. It's a class, but it's a class whose representation and API are derived from a common state vector. So in this case, I say a point is an int x and an int y. That means I get representation for x and y. I get private fields, and I get constructor, accessors, equal, hash code, toString. And if I want to refine the implementation of those, that's fine. I just put it between the brackets because it's a class. If I want to add other behavior, that's fine. I put it between the brackets because it's a class. So, records, they give us reduction in boilerplate, but they're not about boilerplate. They're about semantics. They're about saying what this class is. It's a carrier for its data. And then we derive the boilerplate reduction from the semantic commitment. And like I said, this is a game we've played before. It's worked out well. I think it will work out nicely for records. And it also connects very nicely with the next two features I'm going to talk about, which are sealed types and pattern matching. So record types are also known as product types in the literature. Their state space is the Cartesian product of a number of other types. And in some languages, like functional languages like ML, product types are sort of one of the primitive abstractions for defining data. The other half of algebraic data types, called sum types, is also useful. A sum is a discriminated union. It's being able to say a shape is a circle or a square, and nothing else. And that allows the compiler to reason about, well, if I did something for circles and I did something for squares, then I've covered all the shapes. Sealed types are expressed as a modifier on a class declaration, where you can say sealed interface or sealed class. And so to represent this little mini hierarchy of shapes, I say, okay, I have a sealed interface called shape, and I'm explicitly going to say that a shape is a circle or a rectangle. Those are the types that are permitted to implement shape. If I didn't say it explicitly and they were all code-declared in one class, the compiler would figure it out for you. But you can be explicit about it. And then I say, well, circle's a record that has a center and a radius, and that's a shape. And rectangle's a record, and it has lower left, upper right bounding points, and that's a shape. And a point is, well, that's also a record. And so I've defined a whole hierarchy here of shape classes, including circle and rectangle, fairly compactly. And the compiler can reason. I don't know why it's doing that. The compiler can reason about what a shape means. Okay, so let's move forward. These features work together pretty nicely. There's a lot of places where we might use them. So as an example, imagine you've got a method you're writing a library that's going to compute minimum or maximum value across an array or a list or a collection or something like that. Now, when we're traversing a data set, it's generally easier to compute the minimum maximum at the same time. But if we try to write that ourselves, we would say, oh, I don't know how to return two things, and I don't want to declare a whole class, oh my God, just to return something, so I'll just write two methods, min and max, and I'll make the user call it twice, right? We've all done this where we've cut corners and written the wrong API because it was too much work to write the right API. So one of the things that records do is they reduce the overhead of declaring a new data abstraction so you can write the correct API, the API that you meant to write, as opposed to the one that was easy to write. Another sort of obvious use case here is what was one of the questions that comes up on Stack Overflow about the streams library all the time, which is, supposing I want to do a stream and I want to sort it according to some derived quantity that's expensive to compute. So I don't want to have it computed in the comparator every time. I want to materialize it somewhere, sort by it, and then throw it away. So what I really need is a tuple to describe the element and the derived quantity I'm sorting by. And then I will take my list of elements, I will map it to that, compute the score for every element, and then sort by that, do whatever else I'm going to do in the stream, and then map away the derived tuple and pick out the answer. And this is, again, one of those things that you could do this yourself, but people avoid doing it because it would feel like too much work. And so again, by reducing the amount of work it is to declare the data abstraction you want, and in this particular case, this abstraction is local to the method implementation. That's a local class. You're able to express it so that it's compact and readable and obvious what's going on, and it doesn't pollute your API with exporting an extraneous type. So there's lots and lots more use cases for records and sealed types. Any kind of tree node or document description, objects that simply carry data between two layers in an API, compound map keys, this is one people get wrong all the time, messages in an actor-based system, any kind of wrappers around a value like in the previous example, it doesn't take long to figure out 100 places where you can use this in your code. Okay, so the last big feature I want to talk about, and this is a fairly big feature, but one that we're going to deliver in phases. Excuse me, sir, if you're going to take a call, could you please take it outside? A feature that we're going to deliver in phases is pattern matching. So pattern matching is, again, a feature that, that you might have seen from functional languages. And it's not particularly a functional feature in the sense that it makes perfect sense in object-oriented languages too. So we all write code like this all the time, which is a combination of three things. Asking a question about some object, conditionally extracting some property if the answer to the question was yes, and then putting the result in a temporary intermediate variable. So in the case of instance of and cast, you say if object is an instance of integer, then the next thing I do is cast it to an integer, and then I do something with that. And there's lots to hate about this example. In particular, I have to repeat integer, which is repetition is an opportunity to get something wrong, right? Like let's say I did this by cutting and pasting from some other bit of code, which of course we would never do. It's very easy with this repetition to ask instance of x and then cast it to y. Who's made that mistake? Right? We've all made that mistake. And the reason we've made that mistake is because the language helped us make that mistake by requiring you to repeat yourself. You might say the language is almost daring you to make that mistake. And the other thing that's kind of dumb about it is, well, what else would you do after asking instance of besides cast? Right? Having to do the cast explicitly is just kind of silly. So the essence of pattern matching is to say, let's fuse these three things into one abstraction. So in this particular case, the test is, are you an integer? The conditional extraction is, cast it to integer, and then we want to bind that to a temporary. Some people say, oh, this is easy, just do flow typing, like my other favorite language did. That would be a dumb choice, so we're not going to do that. Flow typing is one of those clever language hacks that looks clever for about 5 minutes until you realize it's a complete dead end and doesn't help you solve any problem other than the use case you had in mind when it occurred to you. So there's a much better answer that goes much, much deeper, which is pattern matching. And so a pattern fuses this concept of test, conditional extraction, and bind into one thing. So one kind of pattern is a type pattern. Type pattern is the simplest kind of pattern, and it looks a lot like a variable declaration for completely non-accidental reasons. And you can put one of those things on the right side of an instance of. You can say if object instance of integer int value, and what that means is, does it match the pattern integer? Yes. If so, cast it to integer and stick an integer in that variable, which is then only in scope inside the body of those brackets. And so eliminates a lot of boilerplate, yay, but also makes it harder to make a whole category of mistakes. There are lots of other kinds of patterns, and they interact very nicely with each other. So type patterns are the simplest. The first phase will just be type patterns an instance of, which will have the beneficial effect of like basically all the casts in the world disappearing, which is like, that's already worth the price of admission. But it's actually a very rich feature. The rabbit hole goes pretty deep, and I'm not even going to plumb halfway down the rabbit hole, but I will talk about what some of the next things we can do with it. Another useful thing of being able to do this is, if you look at the code for a typical equals statement that was generated by your IDE, the control flow is impossible to read. It's if this, then return false. Otherwise this, then return true. Otherwise do this other thing. And that means it takes time to look through it and say, does it do what I think it does? If I express this as a pattern, what I can do is I can bind my instance of and my extraction in one thing, and then continue to use that temporary t in the remainder of the expression. So if the other thing is instance of this class, and its size is equal to my size, and its name is equal to my name, this is a much more straightforward way to express equals. And there are other places we can use pattern matching as well. Right now, when we want to do complex multi-way, like are you an X, are you a Y, are you a Z, we have these chains of instance of and cast, which are like repetition city, right? We have the same repetition we had before, and then we have the repetition of asking the question over and over again, and we have the repetition of doing, assigning to a temporary over and over again with all of the attendant ways to make mistakes. And what we can do is say, you know what? Let's use patterns as case labels in a switch so that I can ask the question once. Does the argument match integer? If so, do some integer-specific thing. Does it match byte? If so, do some byte-specific thing. And this is already a lot less ugly than the code on the previous slide, but we can combine this with expression switches that we saw a few minutes ago and end up with this. And this is, just the facts. This is, exactly what you had in mind when you sat down to write this method, which is if it's an integer, do this integer thing. If it's a byte, do this byte thing, and no extraneous ceremony. So that's nice. Having type patterns as case labels is nice. But like I said, we can go a lot deeper than this. And let me just show you one example of where the rabbit hole leads. So we talked about records. One of the things about records is I am a carrier for my data. And we can derive how to make a record, how to take a record apart, how to compare records from that statement of I am just XY. So one of the things that we can derive is how to use patterns to take apart a record. So for example, what I have in yellow here, this is a deconstruction pattern. Never mind where it came from. There's some details about where it came from. Records would get them for free. But the meaning of that deconstruction pattern of are you a circle? If you are a circle, cast to circle, and then call the accessor for the center and the accessor for radius, take those values, and bind those to those new variables, which happen to have been described with type inference, but I could have said point center int radius just as well. Now this isn't magic. I'm not scraping fields. There's some actual science to how this is done. But it allows me to say exactly what I mean. If it's a circle, get the components of the circle that I care about, and now I can operate them in the body of the if. And I can combine this with the switch statement before. And putting it all together, let's say I'm computing the area of a shape. I know I have a shape. So is it a circle? If so, extract the interesting components of the circle and compute pi r squared. Is it a rectangle? If so, extract the points, compute delta y times delta x. Is it anything else? No, it can't be anything else. It's a sealed type. I already told you that. So the compiler doesn't need to make you put a default clause in because it knows that you have covered all the possible shapes. So these are three features that work really nicely together. A way of describing a class that's a carrier for its data, a way of describing a discriminated union so that you can switch over it exhaustively, and a way of taking apart something that you know is a carrier for data. Now, you'll obviously be able to do this with arbitrary classes, not just with records, but it'll be easier with records because you get that all for free since the compiler knows how to generate it. So this is a pretty nice story that will play out over the next couple of versions. And there's lots more in the pipeline from Project Amber. There's more in the pipeline from other projects as well, which I could, like I said, talk about each of these for hours, but I won't. But I think I have like 4 minutes left with which I can take questions. And I saw there were a bunch of questions. This gentleman had a question, and then Ken. Mm-hmm. Yeah. Yeah, so the question is, well, why not just do tuples? Which is basically isomorphic to the question in lambdas of why not do structural function types instead of nominal function types? And the answer is we could do tuples, but now we would have a type system where some types are structural and some types are nominal, and there's an impedance mismatch where the nominal world meets the structural world. And so because people are used to thinking in terms of classes and members of classes, it makes more sense for Java to express data aggregates nominally. One of the things that you get out of them is you get names. A point is called a point. It's not just a tuple of int and int. And it has a type state. It's a point. It's not a range, which is also a tuple of int and int. And its components have names, x and y, versus a range, its components might be lower and upper. So it's more descriptive for a little bit more work, but it fits better into the Java philosophy. Ken? They are, you cannot make them mutable. They are immutable. The field, when you say a point is int x, int y, that's final int x, final int y.
But do they still have sets?
No setters. Right. Yeah. More questions. Here. So the question is, will I be able to deconstruct something that isn't a record? And the answer is yes, absolutely. But you might be able to do it first for records and then 6 months later for arbitrary classes. We can derive a deconstructor mechanically from the declaration of a record. For a class, you would actually have to declare a member that is like a constructor that runs backwards. So in a constructor, it takes state arguments and balls them up into an aggregate. A deconstruction pattern takes an aggregate and extracts out the pieces. So there will be a way to declare it. It will almost certainly look like a backwards constructor. X equals this dot x, y equals this dot y. But it may be the case that records get them first and then explicit ones come later. So the question is, does it have to, would an explicit deconstructor have to match the signature of a constructor? No. Just like I could have 7 constructors with different signatures in my class, I could have 7 deconstruction patterns, and those signatures might not have to match any constructor, but you probably would want to make it match the constructor because then they compose. Then you can say, take this thing, take it apart, get its pieces, do something with the pieces, feed that back to a constructor, and be able to reason about the result of that operation. So you don't have to, but you'd probably want to. Question in the back, sir. Is there a way to know if a third-party library? Yes, you will find out by running it without enable preview, and it won't run. So you have to explicitly opt in to enable preview at both compile time and runtime. What happens is when you compile a feature with preview, it records it in the class file that this class uses preview features. And then when the VM goes to load that class and it sees it uses preview features and it's not running with enable preview, it will throw an exception at class load time. So I'm told time's up. So thank you very much, everybody. Yeah? You mean non-nullable reference types? All reference types are nullable. Yes, but it is very, very far away in the pipeline. It's a very, very difficult problem, and our feeling is
runtime perspective, there's no like difference whether it's like check or not check.
yeah, right. So I only mean from the whole pipeline. When I write on the routes that are small,
Parang wala sa pakialam.
Check, check, 1, 2. All right.
Hello, hello, hello. Okay, it works. Oops. There we go. Here we go. Here we go. Here we go. All right. So it's 12:30. I guess we can start. How many of you folks here are from ops side of things, like system admins, the deployment managers, whatever? So I assume rest of it developers, right? So developers, any few? Oh yeah, okay, so good. I think this talk will be specifically interested for developers because the observability and all these new terms is just the way how we can get excited developers about like doing monitoring of their stuff, right? And a couple things before we start. This is me. You can find me on Twitter. My name is Victor. You can definitely go and follow me there. You can tweet about this session for using this hashtag. And this is the company where I'm working. I work as a developer advocate at a company called Confluent. Confluent is the company that started by creators of Apache Kafka. Anyone heard about Apache Kafka? Good, good. So yeah, and we built the best managed service that's available there for Apache Kafka. We built best distribution of Apache Kafka, naturally. And we're also providing different the services around this. So enough of that. A little bit about myself. As a developer advocate, this is what I do, essentially. So you should expect demo that will consist of like a highly scalable hello world application that will show some of the things. And actually, this particular title was coined by Kenny Bastani, and props to him. Hopefully, he's in good health right now. So I do have a raffle here. If you would like to participate, it's easy. You need to follow me. You need to follow Confluent, post pictures, tag me in these pictures, hashtag Oracle code, and I will find you. It'll give you, most likely it's going to be a gift card. All right, so enough of that, so we can start to actual topic. All right, so since you are developers here, we know how everything started. We're starting with small POC. We're writing some of the system. We're starting with something small. We're just trying and seeing how the things will work. Some of the small module that will prove the certain framework works. Some of the new language that you're learning is working, and you might be doing some of the things. And over the time, you actually start adding more since your requirements start growing. You're gaining more and more the modules in your system. And it's still manageable for one person because you kind of can fit all these modules, all the subsystems in your head. So in this case, it is still manageable. Now, this over time, it grows into different sizes of subsystems, and things getting bigger and bigger, and it's getting darker and darker because it's much more difficult to keep things in the head of one or two or a team of developers. It's becoming a very, very unpleasant place. And at some point, you might even find some dead code. Someone try to hide some of the daily secrets or whatnot in the system. So, and when you're trying to explain this to someone, to a new person who joins your team, or the person who's trying to operate this in the production, if you're not employing the DevOps practices, you might sound like this. You will try to explain every possible path in your system if it's not well organized or it's not well designed, because you build a system. You was very busy of building system, right? You was very busy of bringing value into your company. And over time, you start kind of outsourcing this knowledge to different systems that will take care of half of the system. And essentially how we did this for a while in the past, right? Does things like Zabbix, Nagios, does it ring a bell to some of the developers? Usually if it's operations people in the room, they, yay, Nagios, we still remember it. So essentially every system, if you're using enterprise system, like using some vendor system, will usually ship with a set of monitoring tools, set of dashboards, and you need to learn this, or like your operations people need to learn this. So, and different systems, they have different notion of monitoring, different things that they monitor, allow to monitor, and different things that they probably different opinion about what they monitor and how they monitor it. Usually before DevOps become a thing, before the cultural shift in organizations, when you start owning the code that will be running in production, you just call it some IT stuff. Like we just like give it to IT guys. They will monitor, they will set up alerts, and they will be on duty, and someone will call them if the system will go down. And after that, through the escalation path, they will kind of sort of end up and learn who's responsible for this code or who wrote this code, right? It's very difficult to say, like, application can report that it's still alive. For example, it has some of the set of HTTP probes, the easiest thing. And this HTTP probe will always respond to 100. Yeah, application is alive. But connection to database is broken. Because your system not only represents like your system or your web app or whatnot, it also represents connection to multiple other systems, including databases, messaging system, et cetera, et cetera. And how many of you have been in this so-called war rooms? Have like a big table, and the people look like they gathered there for like a Justice League meeting. You know, there's a Superman sitting in the center of the room. Or how many of you have seen this Boys TV show recently? There's another character which is mocks Superman. It's called Homelander. He's always powerful, and he sees and he has the power to, you know, to fire or to kill. So it's basically a blame game, right? And the different people come into this war room and say, "Oh, so our system is working fine. It's not our fault." And the different other people are coming. So, and yeah, it reminds like a war room because they're trying to figure out what the hell is going on. Everything starts like this. You have a customer that calls in, and you're trying to figure out why their system is not working. And this red line represents the time, essentially, where your customer is complaining, your customer is not happy, to the point where you can say, we're fixing. But this time for troubleshooting can take days, weeks, hours, who knows? Because sometimes fix is simple. As a developer, you can say, oh, we can ship patch like right now. I can just go to production and just replace few classes there just manually. How many of you have done this before? Just go there, you pass your CI/CD pipeline, you just compile this new Java class, just went there, just drop it in the class path without even packing to jar. I did this. I was a consultant. I did this all the time. Do I proud of this? No, but it helps some people go to sleep so we can work on the root cause analysis and figure out the problems after and try to not allow these things to happen. You know, there's some situation where you need to fix something. Like just go and fix it. Customers will be happy. We can go have a couple hours of sleep, and after that, we will figure out how not allow to make this. And what the DevOps is actually teaching us is not a blame game anymore, right? So all the things where deploy often, deploy your code, like every commit, every push, it teaches you that changes, they're not that scary. They're not supposed to be scary, because with the proper culture of delivering these things and the proper culture of monitoring, we will return to monitoring, observability, and how they connect it. Changes are not scary anymore, right? Yep, this is something that we don't like, right? So this situation is not super cool. So let's go to the subject of observability. So I established this importance that probably you already know that this is an important thing to know. And this term of observability, it's just a fancy word to get developers excited about things. You know, developers, the backend engineers, they care about performance, they care about some of the instrumentation, like real-time performance metrics collection, blah, blah, blah. But essentially, providing the ways how you can collect useful information to make a decision that something is working or something is not working, right? So this is what essentially we're going to be talking about. Observability has or resides on top of 3 pillars. And by the way, Cindy, she's authored a very awesome book about distributed tracing and observability. And some of the ideas specifically about the pillars of observability, they also will borrow from that book. So let's start with these 3 pillars of observability. This is the first pillar. Who can tell me what is that? It's not biceps. What he is carrying? A log. Okay, so maybe this makes more sense for you, right? So this is something that you can relate. You know what is this. So log, what is log? Log is a sequence of timestamp events. Usually, it is immutable, unless you're trying to, hide something or stole some money from your boss, and after that you can hide this, go and edit these logs. But usually logs are immutable. So, a couple things we have here is, again, time. We know that something happened within a particular moment of time. We can also say what was the severity level and the component that provided this. Usually info allows you to restore a sequence of events. You know that, okay, so everything's good, and after that you've seen something, we don't see errors here. Warnings. Warnings mean that we need to pay attention to something. And usually logs are giving idea or giving history of the events that happen with the particular service. In order to make sense of the things that happen in the system as a whole, you need to introduce the new discipline. It's a log aggregation. So, and after that, based on time And based on certain things that happened within this time period, you can create this correlation between how different systems behaved in this moment of time. So in this case, the log aggregation will allow you to kind of establish one-to-many relationship, like how many systems were involved in this particular incident. Second pillar, metrics. Everybody loves metrics. In the contrary to logs, metrics describe not the individual event, but they describe certain things that happen in aggregation, right? So within 5 minutes, we can say that total throughput of particular socket or particular the channel on our message bus was X. And this is something that is not applicable to our SLA, to external customer, or to our SLO. So we're seeing that, okay, these metrics are actionable, so we need to take some sort of action based on these breaches. So in this case, like you have a time slice, and you can figure out what you know. So what we know right now, the whole history of things, and we have the metrics that gives you some like aggregating thing that will give you certain view to the system. However, when we're dealing, always remember how we started here. So we started with the small things. Yeah, we wrote a small service. Our small service has logs. We can get and download all these logs to investigate all these problems. We can actually collect some metrics. We can use either framework or write the metric collector ourselves, and so collect certain actionable metrics. You know, people love metrics. I would like to ask every time when I'm in a room with the users of Kafka, and since I was working as a professional services engineer here at Confluent for a while, people want to know what the metrics they need to measure, and they love to see all these dashboards. It's another thing that engineers love to see. But some of the things that I want you to have in mind, like two things actually. So first things, you need to figure out what metrics are actionable and what metrics are not actionable. You need to know, okay, you see this throughput dropping, but what does it tell you? Do you know, like, is it permanent? Is it a spike? Is it happening? Is it pattern? You don't know. And another thing that, do you really care about certain metrics? Yes, they might be out of certain boundaries, but do you really care? So always, if you're thinking about metrics, collecting metrics, yeah, it's good, it's nice, it's better not to have those, but you always think that, all those metrics require me to call someone in the middle of the night because something is misbehaving. For example, we have engineers, the support engineers who work on managing some Kafka infrastructures. They have a huge experience of managing messaging systems, and they also trying to translate their past knowledge to things that they have with Kafka, for example. And one of the things is that they see in the messaging systems, JMS or Rabbit or whatnot, they see that number of messages in particular topic is increasing. And after that, they start calling to developers and, hey, looks like this application is not doing something right, okay? It's a number of messages in topic is increasing. But in Kafka world, it's okay, it's fine, because Kafka, it's kind of like a database. It can accumulate messages, and messages will not disappear after someone will acknowledge those. And all these things that, yeah, he sees this number of messages in topic is growing. Is it actionable? He thought it was actionable because on his previous experiences was actionable because it's the indicator of something bad, but it's not necessarily true. And the third pillar that we're going to be focusing right now is the tracing, and specifically distributed tracing that allows us to have a whole picture of the certain request or certain piece of code will be executed in parallel with some other bits of your application. Now, tracing is a very nice tool that allows you to establish cause and the result the relationship. So your systems, you will be able to figure out that this is something that happened or time took so much time that like it affected certain things in our application. We always know what kind of service is involved. Usually it's kind of like a swim lanes that define what kind of service spent certain time doing such and such things. We'll know how long it takes the service to do things, and where actually failure happened. And after that, you can still apply all these things that you already have. You can still go and investigate what a certain service failed through the logs. You can go and drill down and see all this kind of log information. Interesting observation. I recently saw in some of the presentation that was done a week ago at the Strangeloop. The distributed tracing is like Chrome developer tools, but for something else, not for web apps. How many of you have seen the Chrome developer tools? How many of you have seen the network side of the Chrome developer tools? And you've seen this kind of like how much the request will take, how much it takes to download image, how much it takes to download CSS. It's a cool thing, but how we can get this from your distributed system? So the way how this understanding of the things and the way how this evolution of thinking about the system or making sense about the system happened is through the way how we understand the concurrency. I'm oversimplifying certain things here, but let's start with something simple. We have a web server, run some PHP code. From this PHP code, you establish database connection. You go into this database. You're getting some result from this database and rendering the result in the HTTP page. So everything happens within one request. Easy to trace. You click the button, your PHP code executed, your database code will throw error, and you know that this is where you failed. It's easy to understand it, easy to figure out where the problem is. Now, enter the world of enterprise Java. So the enterprise Java allows us to run multi-threaded code without thinking about threads per se, right? So you know that the container will provide you with certain resources, so your code will be executed there, and you're not managing your threads there because the threads were not, like managed thread, were not the part of specification for a while, and some of the implementations might provide you with some managed threads, but difficult to figure out. Again, it's still one system, still in the context of one Java EE container, Java EE application server. You still can go and look up into in the logs and figure out what is going on, what is the problems here. Now, enter the world of Node.js, where we don't have the threading per se at all, because it's happening in the one loop, in the one thread, and there's going to be different context switch between these things. And there's also kind of things getting complex because code becomes asynchronous. You cannot just call something and after that, based on how fast this method will return, you can say, yeah, this method was fast, because you don't know how fast it will return. Because usually you just call it, and after that you have a listener, you have a handler that will be called by underlying runtime. And now we're in a world where all the people on the conferences, including myself, telling you that, hey, monolith is bad. You need to build microservices. Microservices is awesome. Microservices is something that you build, and with the pizza box size teams, you have 2 people who can eat the box of pizza, so yeah, they will build your microservice. Now, this microservice needs to communicate. Microservices, they need to talk to different microservices. As many of you know that having shared state in database is a bad thing. So that's why each microservice will have its own database. How you will synchronize these changes, maybe there would be some underlying backbone we're going to be talking about in a bit. that allows to replicate this data from one place to another. So how we can trace it, like how the call from one system, how we can trace from the place where like one system will call something, another system will reply. So situation like this. So again, back to the picture, back to this like a small, beautiful flower with tiny thorns. We start simple. Our microservices has its own state, its own database. Our microservices need to talk to different applications, maybe expose some of the APIs or calling some APIs. Maybe offload some of the data to data warehouse for analytics. And integrating with third-party tools that might be not even on-prem, somewhere that you don't have a control over quality, and you can rely on certain contractual the things that your customer will provide, but you don't have any other control. So you're building these things in the fashion that other people are building. You're building this, and now go trace that, right? So go figure out where, or like someone brought you some bad data, or someone, or you maybe affect some other system. How you can trace it? How we would know that? So this is why we kind of focusing on building this thing, what we call streaming platform, and Apache Kafka is the foundation of this streaming platform that allows to establish central place of exchange of information. So that's why microservices can communicate through this bus. Some of you might be remembering the time of ESBs, but I think it's a little bit different because ESBs were more about messaging means and the way how you can route things. But streaming platform and Apache Kafka, they also provide the ways how data can be persisted, so you can all get different results from the same data if you do want to change the algorithm, how this data will be communicating. So few words about Apache Kafka. So what we believe is that what we see from, again, maybe we're biased, we have this confirmation bias because we're a Kafka company, we're working with customers who use Kafka, but we increasingly see that Kafka becomes a central place where the people put stuff that they want to share with other teams. They're not exposing some of the systems through some sort of API. They steal some legacy system that exposes API, but it would be much easier to place them into streaming platform where they can do things. So this is why we're kind of thinking about this, and maybe very soon Kafka is becoming the central neural system of organization to exchange the data. Now, so this is why I'm going to the point where the streaming platform and observability of the streaming platform becomes another interesting, challenging tasks. Not only that this streaming platform provides you tools that can, for example, establish your central logging system, and many people use Kafka as their log aggregation system when they're collecting logs from multiple places, and microservices, some micro services, bigger services, some services. This data will arrive through Kafka to some other system that allows you to do something useful with its logs. For example, parse it and provide the ways how you can search certain problems or establish alerts. So it's interesting. It's interesting problem right now. It becomes an interesting problem because it's more chicken or the egg. So you need to, from one point of view, you need to have a system that allows you to provide observability, and you need to have observability of the system that provides you observability. So this is what we're going to be talking a little bit today. Couple things about distributed systems, distributed tracing tools. There are good number of open source tools, and the good thing is that open source is killing it in a good sense. Like it's really good that there's so many open source tools that you can use today for free to do your observability task. One of the first implementation of this observability patterns, so this distributed tracing patterns, was implementation of Zipkin. After that, Jaeger was open source, was developed and open sourced out of Uber. And the standard around these systems become become a thing. So open tracing and open census, which was like a Google implementation, and they now joined the open tracing as well. So the open tracing provides the way how these different systems should implement the tracers, the components that will, or reporters that will be writing data to this dashboard, in this particular case, either Jaeger or Zipkin. Cloud providers like Datadog, they also have kind of open tracing compatible endpoints. So you can switch between different, same promise with the Java EE, right? So we already fed enough of this standard thingy because, okay, they told us we can switch between different data, between different application servers, but in reality, it was not that easy. But in practice, we all develop everything on Tomcat, and after that, run production on the WebSphere. So I would consider this as a win. So this is not the case with open tracing. It's actually pretty good, and there's the way how the people communicate over certain capabilities and certain features is actually outstanding. So it allows you to follow simple programming, simple enough programming model to integrate this. And with the rise of container management software like Kubernetes, some of these things become a part of the package. Some of the things have become just something that you're getting out of the box. So the Jaeger was open sourced by Uber, and it joins Cloud Native Software Foundation. Together we're the same place where the Kubernetes is. So the ecosystem is growing, and integration is better and better. So there's no reason not to use this kind of tool. So, and it's also becoming more and more popular in a sense where we have a more and more heterogeneous system, and the service meshes. This is another concept that came from this Cloud Native Software Foundation, and the idea that your services not necessarily needs to know about the existence of each other. So the service mesh allows to perform this routing. Those tools also integrated with the tracing. All right. Now, so this is why we're here. So distributed tracing for Kafka. Kafka is quite popular software. So pretty much every time if you're trying to Google something that should work with Kafka, you will definitely find, because a lot of people use Kafka and a lot of people write different integrations. So there's no secret that one of the projects it's kind of that they have this open tracing GitHub organization, and there's the open tracing contrib, which is a place where different people, individuals or companies, they can contribute their the systems or their bits to integrate different systems. So in this particular case, if you will start looking something like open tracing Kafka client, so in this particular case, you will see this stuff. So what it does, it supports open tracing API and for Java client. So Kafka implemented in Java and Scala, and to my pleasure, so less and less in Scala, more and more in Java. The API itself allows you to instrument the consumer and producer. And also, it actually follows two interesting patterns. So first pattern is actual instrumentation. You build a decorator, you're creating your producer class, and you pass this into this tracing decorator. And after that, they follow the same interface. You can pass this the class whenever using this producer, and it will behave as a regular producer. Only one thing, it will be intercepting some of the calls, and will ship this metrics to Jaeger, for example. Another approach that is more, see if I have an actual slide for this one. Yeah, so another approach is to use so-called interceptors. So in Kafka, there's a concept of interceptors because Kafka itself don't really care and don't really give you way how you can introspect. So only way how you can get some of the information you need to instrument your clients. So, and with the standard interceptors, we can actually get some meaningful information. So the way how the different monitoring tools work, they collect data from a client, producer, and consumer, and report to the monitoring system. In the same way, colleague of mine implemented some of the tracing capabilities here for some of the system. Now, the two different things. The first thing, when you're using decorator, you need to have access to actual code. You go in there, you change in the code so this decorator can be used. You can apply things like AOP and kind of like inject this agent and do this in runtime, but it looks like nasty. Another approach is using interceptors. It doesn't require you to change the code. Use interceptors is just a configuration change, and after that, your application will become instrumented. So that's easy. So let's take a look what we're gonna be doing in this demo. So in this particular case, I will be demonstrating some of the approaches how we can instrument system that I do have kind of source code. I can go and do certain things with, and the system where I don't have a source code and I just want to get under the hood of this one. So let's take a look on the demo. We still have plenty of time, so let's not break the equipment and stuff. All right, so couple things. Do you see it well? All right. So we at Confluent, as I said, we developed this just distribution, our own package of Apache Kafka. This one allows us to just simply run these components in one command. We have this Confluent CLI that allows us to operate with this one. So sometimes when the people get started with the with things like Kafka, they need to bring like whole family in law. They need to bring Zookeeper, you need to bring Kafka, and after that, you will want to have a place where you're going to be storing your schemas for your data and yada, yada, yada. So we just ship it in one package. So it's easy to develop in one place using this command line tool. Second thing, while it's starting, I will show you small application that is basically a Spring Boot application. In this Spring Boot application uses some of the integrations that Spring Boot provides for Kafka. So my application just starts. I create a Kafka topic, and this is pretty much it. In my application, I do have a producer that will write some data in the Kafka topic. And the producer in the Spring Boot world, if you ever use Spring Boot or Spring integration for any system that you need to produce some data, you usually rely on some sort of template. It's a JDBC template, a Raven template, Kafka template. So similar model. And the way how it works, again, sprinkle of Spring magic. Basically, I have this application config that specifies where's my Kafka running, what kind of name of my application, and some of the things that we will be using. So in this particular case, this interceptor classes config will be injected in my producer, and it will be injected in my consumer over here. So in this case, all these things will be instrumented, and my code doesn't know anything about this. So second thing that we're going to be using another component that will be responsible for kind of like a processing part. So we have a producer and consumer with writing data and reading data, and we have another microservice that needs to do something with this data. They talk through to each other, to Kafka. So let me do, I will show you config change for local stop KSQL server. So we're going to be using this thing called KSQL, which is, I would say, a stream processing tool for rest of the world, because you don't need to be a programmer in Java. You don't need to learn like Kafka streams. You need to learn like Spark streaming and stuff. If you have any memories of your past when you learn the SQL, you can use SQL to write stream processing applications. So let me see, current. I need to find a place where I put my KSQL server, and here I will just do some configuration change. So KSQL server provides a KSQL config in the server properties. One of the things that I need to put here, by default, it comes with these the monitoring interceptors. In this case, it will be possible to integrate with some of the visualization tool that we have. But in this particular case, we don't need that because we already configured this. And I can specify multiple interceptors. So if you're using like distributed tracing, doesn't mean you have to drop off your monitoring system. So in this case, I would just need to specify those in separated by comma. There's two different types, a producer interceptor and consumer interceptor, just because the API is slightly different, so you need to make them work slightly different. So let me save it, and I just do start, so 1 second. Another thing, in order that this simplify things or simplify this integration with this Jaeger guy, I need to specify this service that this particular, it's called trace, how it's called, tracer. Yeah, so in order to make sense of the things that we do with this application, we need to give some meaningful name. So in this case, we will call it, so let's call it intercept, let's call it service. So in this case, everything that our application will do, like this particular KSQL application will do, will appear in the Jaeger dashboard with this particular name. And I need to run this Jaeger guy. So I'm using, I can run this with Docker. I don't have it here. And just, where is it? I just starting this. Docker is just a simple way how I can bring things in. If a couple things that I want to show you now. So let me go here. My Jaeger starts. It has some data from, no, okay, so it was refresh, start KSQL server. And let's see if we have liftoff here. And I need to start my my application, my Spring Boot application. So again, Spring Boot application consuming producing data. We will be able to see this in the Jaeger dashboard in a minute. So if I go here, there's a service called Spring Boot. And the way how I registered here in my application is just in the configuration. I just specify that this is a global tracer that allows me to integrate with the Jaeger. This is the name. And after that, it will just start reporting through UDP. And since my Jaeger runs here on certain UDP board, it will just capture all this data. Now, what you can see on this console, my producer will write some data, and my consumer reads some data from the topic. And if we go here, just let's do 5. We will see something interesting here. So we have 2 stages in this application. One stage is we're writing to this topic we call stage 1. And in this case, this is a component that we have here called a, where is it, producer. It knows that this is Kafka producer, and the type of span is producer. And span is actually the time, how long, I didn't mention this in the very beginning. So the span, it's a time, how long it takes the one request to perform. In this particular case, span time is like 0.1 millisecond. And in this case, span is a consumer. So 2 things that we see here. Already we're getting some of the useful information here. So we know that some of the data from the topic stage, let's see. So let me go ahead and refresh and show you what kind of topics we have here. Okay. Stage 1, this is the topic that we're using to, where is that overview? And I can see what kind of messages here. Just same messages that I'm populating here. I can see it here as well. Now I want to do something useful. So I will start doing things like performing my queries. So in this particular case, never go to demo without predefined queries. So you need to close your eyes for a second and like I kind of like a fast typing, and boom, here we go. So I'm creating this small application that will allows me to operate with this so-called stream. So I materialize this topic into something that can operate. In this particular case, we call it a stream. So when I run this, it creates a stream over here. So this stream, I can do queries. So one of my favorite queries is select star from everywhere. And now this query will be able to print out all result from this particular topic. Some magic is happening. Hopefully, it's happening. Let's see. Let's just see. Like we can always see what is going on. Why it's not running. Interesting. Let me see if I can do this again. Okay, run. Check connection settings. Okay, so probably something is not right. Going again. Yeah, KeySQL server is up. Is up and running. It's working. So everything is up, but for some reasons the control center cannot connect to this one. Let me see. Trying again. Always persistence. Just try, and something will happen. Hopefully. Let me see. My application is still running. Yes, application is still running. We still have some data, which is also totally fine. We can always switch from the fancy UI. We can switch to KSQL. To command line tools that will always show. Okay, show streams. Okay, select star from stage 1. And okay, let's see. Drop stream. We'll try it again. It's always okay. So show. Okay, it's not there. Okay, trying again. Topic stage 1. I will go and just query in KSQL stream name or wrapper. When coding, it's JSON, integer, save stream. All right, so come on, do it. Yes, it's working. So it does pushing some data. Now, can we see this? How these two applications actually interacting? So I'm getting back here into my Jaeger, and let's see. So first of all, I can see now the service registered here. I have 5, 6 find traces. And now I can see things from how the data arrive here. So data goes from the application goes to stage 1. Next, it goes to, we're reading from stage 1. And from stage 1, we're also doing reads for other queries. So let me show you a couple more cascading streams. So in this case, I guess I was just stage 1, stop run successfully. Now we should be able to see. So I created another stream. So in this particular case, I created stream stage 2 from another stream. So it's kind of like I'm trying to create a cascade and show how the this pipeline can be used to investigate what is going on here. So find traces, see Spring Boot, data is not there yet here. So in this case, we have already multiple stages. So we have data that produced in Spring Boot. We see data that was consumed from Spring Boot. Now we have another application that uses the same kind of like a trace ID, and they understand this is the part of the same transaction. We can now go and drill data down and down and down. So this is pretty much it. Quickly, if you in this the Kafka type of jazz, we're actually doing the Kafka Summit in a couple of weeks. If you are local or if you're interested to come, you can use my personal discount. It gives you 40%. And that would be it. I will post the slides and post the code in Twitter, so you should go follow me. I'm a very interesting person. And thank you so much for your time. Thank you so much for sticking up. And I'm available for advanced interrogation as soon as I will clean up this place. Thank you so much.
Are you staying for the next session, sir? Are you staying for the next session?
Послушай, Витя, ну ты крутой у тебя.
batteries here.
Check, 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 check. All right. Check. Can people at the back hear me clear? Yes? Okay, cool. All right, so let's get started. So my name is Pradeep, and this is Luke. We are both production engineers at Facebook. We specifically work on the MySQL infrastructure. So we are here today to basically share about how we manage production MySQL deployment at Facebook, and we'll talk about different components of the MySQL deployment. So here's the rough agenda for the talk. I will be talking about some of the concepts here, and Luke will be talking about some of the concepts. So we are basically going to discuss about how a MySQL instance at Facebook enters production, how it goes through various phases, and how it actually leaves production fleet. We're going to talk about how we copy data around in Facebook fleet, how we migrate shards, how we do balancing based on different parameters, and how we basically test our code to basically iterate faster to manage MySQL at Facebook. So before we get started, I wanted to quickly go over some of the terms we use frequently in the presentation, and that would become easier for you guys to follow the presentation. So I wanted three main things, basically. What's an instance, what's a shard, and what's a replica set. So an instance is nothing but a MySQLD process listening on a specific port, and it serves some part of traffic. So our host can have many instances depending on the underlying storage space available. We have a concept called shard. A shard is nothing but a simple MySQL database. The names can be arbitrary strings, or they could be some ID forms. And then we have something called as the replica set. This is what is frequently used. So a replica set is nothing but a collection of one master and n replicas. These master and replicas are located in different data centers. And depending on the topology of the underlying use case, the number of replicas can vary. So this is a typical example of how, the www looks, facebook.com is served. So you have the front-end web servers, and then you have the service discovery component, and then you have all the way in the back end some sort of replica set. So the service discovery framework is the source of truth for figuring out where a particular data lives in. And this framework is generic at Facebook. It is used for a variety of other purposes as well to figure out where things are. So if you can imagine a service discovery to be some sort of a big hash table, and you could ask for it like, hey, I have this shard. What is the writable copy of this shard? So all the client APIs are going to do is reference this table and get you the answer and the connection for that particular MySQL instance. Same goes with read-only copies, and also if you have any locality preferences, you could also use that information in the API to basically look up this table and get the right connection. So one significant advantage of having a service discovery framework like this is we can do our maintenance operations in the backend almost invisible to the user. So for example, let's say you have an instance and it has some sort of kernel upgrade or some sort of maintenance operation. All we have to do is basically disable that instance in this discovery framework while we work on it. So all the connections will automatically fall back on the master copy. You have a master which dies because of hardware failure or some sort of disk issue or whatever the reason might be. We can also do live promotion when we detect this and make the replica to be the new master. And while this has happened asynchronously in the background, we can initiate copy jobs to build a new replica. And once they are ready and caught up with replication, you can basically populate the table back. So this is how roughly, like, instances, clients basically use APIs which follow this thing. And all of the maintenance operations and promotions are very invisible to the application or the user. Okay. So let's talk about all these concepts together. So for example, you have the shard, db.helloworld. A shard always belongs to a given replica set. So let's say it belongs to a replica set 1, 2, 3, 4, 5. A replica set, as I mentioned, is hosted by different MySQL instances, having one master and n replicas. So in this case, let's say the instance in Prineville, Oregon is the master on 3306. And then you have in FTW, Fort Worth, Texas, you have the 3306, which is a replica, and another one in Forest City, which is another replica. So this is what roughly, if you put all of the things which I talked about, this is what it looks like. Now, as I mentioned earlier, a single host can have many MySQL instances. So the same same host, host123.prn, can have another instance which is serving a completely different replica set. So we have db.foobar that's hosted by another replica set 6789, and that has instances co-located in that machine. So, so all application owners and clients care about are shards, and rest of the thing is abstracted away from them. Okay. Next up. So let's talk about life cycle of a MySQL instance at Facebook. So every instance at Facebook has a state. A state indicates what the instance is basically doing at that point in time. States can be production, spare allocated, spare deallocated, reimage, and drained. Each of these has specific meaning. So as the name indicates, production is basically that is active at that point of time, and it is serving some sort of traffic, read or write. A spare is another state where you have instances just lying in the pool, and they are ready to be used for replacing an existing production instance. Spare allocated, deallocated, reimage, these are transitionary states where you're actually doing some sort of maintenance operation on the instance. And drained is another state where you want to do some sort of investigation, like why MySQL process is not behaving the right way, or you want to do some sort of temporary maintenance and you don't want to initiate a copy for an existing instance. Every instance has some sort of metadata. The metadata has host name, port, the specific RPM version, and state, what I talked about. All of this is materialized in a MySQL shard, and that shard is the source of truth for what that instance has and how does it look like, and that is used by our automation code to make decisions based on that shard. Okay. Right. So let's walk through a couple of use cases here. So this is roughly a state transition diagram, and each of these states has an asynchronous processor, which basically handles an instance in that state. So, okay, let's talk about a case where you have a production instance which is broken, and you need to replace it. So what would essentially happen is our automation would detect that, hey, there is a production instance which is broken. It will call an API to find the right spare which matches the current production instance. So it'll go to the chart, specify a bunch of columns, and it'll match the available spare for that production instance. It'll allocate that for copy by moving from spare to spare allocated and initiate a copy process. And once the copy is complete and it's caught up with the replication with all the latest events from master, you mark that instance as production, and you take the existing production instance and move it to spare deallocated. So another workflow could be, now the instance is in spare deallocated. We have a set of predefined checks where we determine, can this instance be fixed somehow automatically and put it back to spare? Or if something fails, we basically send it to reimage, where it is sent through an entire provisioning cycle, and it comes up with operating system reinstall and disk reformatted and things like that. So each of these states, as I mentioned, has a processor which is basically written in Python, and they keep continuously scanning the fleet to get instances in each of these states and perform actions on them based on different metadata for that particular instance. So yeah, that's about lifecycle of MySQL instance. And the next topic is how do we do copies? I will let Luke continue that.
Test. So yeah, next I will go through a couple of basic tools we have in Facebook regarding how do we do data migration in terms of moving data around, and then later on I will piece all those components together to explain how do we do balancing based on those key components that we have in Facebook. So first, let's talk about how do we build a new instance using the existing data set for different purpose. So first I will talk about the different scenarios where we actually want to build a new instance using the existing data set. So essentially, host can be broken, or the MySQL instance can be broken due to various reasons, like replication failure or hardware failure. So in that case, you want to spawn up a new data set in a different healthy host, or a new instance in a healthy state to replace the broken one using the service discovery that we just talked about. Sometimes we want to move the data around in order to perform maintenance on certain asset, like racks or hosts, or even a power supply circuit. And then also we do move data around just simply for balancing purpose, so that for each individual host, we can achieve the maximum utilization for all the resources that we have on the host. So we use a tool we call MPS, which stands for MySQL Port Scanner, to manage all those data migrations on the instance level. So the tool itself will just simply go through the couple of stages that we'll cover in the later part to build up a new MySQL instance using the existing data set. Let's go through the stage one of the other. First, we do allocation. Essentially, it's fine. Its job is to find the best slot for holding the data we're moving. And then it would take multiple factors into account. For example, the disk usage and the CPU footprint from the existing workload. And also it will consider spreading across multiple failure domains in order to have better fault tolerance. So once we know where to copy the data into, we'll start to set up the environment to be ready for holding the data. It does a couple of sanity checks and bootstrapping process. For example, making sure the host is at least healthy and there's no known hardware failures on the destination. And then install the right RPM version according to the setups we have for this specific data set. And then generate the right my.cnf, and then make sure the empty instance itself is in a healthy state to move on to the further migration. So next is the actual physical data migration. So for this step, we have different mechanisms to move the data around. Can divide this into two major categories, physical copies and logical copies. So we normally do a online physical copies for setting up a new instance, simply because the speed. So now that the whole fleet is on Flash, so we don't actually have too many production traffic effect while running online physical copies when building up a new instance. So for InnoDB engine, we use extra backup to take a snapshot in an online fashion and move it onto the destination. So for MyRock's engine, we use the similar tool, which is called MyRock's Hot Backup, to move the data around across different hosts. So under some scenarios, the physical copy is not feasible for us. For example, like if you're upgrading the MySQL across major versions, like say if you want build a new instance, new ATO instance based on the existing 5.6 dataset, the physical copy doesn't support that. Or if you're migrating across different engines, like for example, you want to build a new Marox instance based on the existing InnoDB instance, these are all not supported by the physical copy. So we have to do a logical copy to set up the base dataset. So in that case, we have two different ways to set up the dataset. One is to do an online MySQL dump, which is pretty common tool that being used in the MySQL world. Or we can restore from the most recent backup, which is also generated from the MySQL dump. But by restoring from backup, we save the cost of running a long snapshot from the existing online services. So once we have the snapshot being bootstrapped on the destination host, then we need to set up the replication properly to be able to replay all the events that happened during the previous couple of stages so that the new instance can keep up with the master and getting ready for the upcoming production traffic. So there's not too much magic happening here. Essentially, we'll start the replication using the bin log position that got recorded as a part of the previous step. So under some scenarios, we were not able to connect it directly onto the existing master for fetching bin log events, simply because the data migration step might take too long, and then the master might not have all the bin log events that will be needed for the catch-up. So in that case, we have an internal component which is called bin log server that will serve as a intermediate master, and then serve bin log events by reading from the bin log backup device. And by using bin log server, we'll be able to cover the gap where the current master wasn't able to serve. And then once we caught up to a point where the bin log GTID range can be covered by the existing master, we'll switch from bin log server onto the existing master and keep the replication from there. And then after setting up the replication properly, we will simply just pulling the current second behind master on the new instance to make sure its dataset is close to a point where it's up to date and ready for production traffic. So next we'll go through a data validation step to make sure the new instance that we built doesn't contain any data drift or corruption throughout the process. Because you may know that any software is vulnerable to human error or hardware corruption. So we want to make sure the new dataset is consistent with what we have in the production environment. So in this stage, we'll use a checksum-based mechanism to compare the result from the checksum sequence between the current master and the new instance to make sure the data is identical between those three instances before putting them into production environment. So after data validation, the new instance is now ready to serve production traffic. And as we just explained, we use service discovery system to put this new instance into an enable state so that the clients now will notice this new instance and start to bring traffic onto the new node. And then once that is done, we can pull the broken ones outside of production if necessary. So apart from moving instance around, we also have this tool called online shard migration that will be enable us to move database around across different instances, which is a different level of data migration. So the idea of moving database around instead of using moving instance around is normally we find the application or the business can grow out of control at some point where a single instance would be able to hold the data anymore on a physical host. So in that case, we will have to break the instance into multiple pieces by moving the database around to control the size or the footprint of each instance. So that's where we will need this online shard migration. So the tool we use for online shard migration is called OLM, which stands for Online Logical Migration. So the key concept of this is prepare the data into a new destination in an online fashion, and then catch up the events that are missing during the migration, and bring the new data set up to a point where it's close to the existing data set, and do a address switch or registration in the service discovery to repoint the clients onto the new data set to achieve the purpose of splitting an instance. So here's a diagram showing how the online logical migration will be performed. So on the left side, you can see a fairly large instance on the left side containing two databases. One is database 1, which is 100 gigabyte in size. The other is 300 gigabyte in size. Assuming the host can only hold 500 gigabyte, so we're close to a point where we're going to fill up the disk. So we want to move one shot away from the existing instance so that we can continue to serve the traffic. And on the right side, we have a relatively small instance, which is only 50 gigabyte in size. So here we want to explain how we're going to move this database 1 onto the right side. So first, we'll create a empty database on the right side to be able to hold the data. And then we'll use logical snapshot, which is a similar concept as the MySQL dump, but essentially start a transaction and start to dump the data onto local disk using a CSV format. And then break into smaller chunks so that we can gradually load down to the destination side. So once those two steps are done, we have a stale copy of the data on the right side now, which is fairly close to the left side, but there's still quite a lot of changes that are missing during the whole preparation stage. So then we'll need to replay the changes by using bin logs and filtering only the database that we are migrating, and then replay onto the destination side. And then we'll keep this keep doing this logic in a couple of rounds up to a point where the data set on the right side is milliseconds behind the old data set. And then we think now is a good time for the actual final switch. So now that the data set on the right side is fairly up to date, we'll do a update on the service discovery system to repoint database 1 onto the new replica set, which is the address of the data set that we have already prepared. So once the new address is registered, all the clients will start to noticing that the address the destination of the shard has been changed, and then they will start to talking to the new replica set. And then once we verify there is no client-side error and there is no orphan connections or leftover connections on the source replica set, we'll just drop the database on the source side to finish the whole logical migrations. So here's the same example of the logical migration, but on a different perspective. So OLM is essentially just preparing the data set and then register the new address in the service discovery system to perform the logical migration. So on the left, we have the old replica set, and then during the data migration, we clone a whole replica set using the existing data. And then essentially at the end, we do a registration in the service discovery to finish the whole migration. So on top of that, we also have a logical migration processor to be able to manage this shard movement at scale. Because the tool I just talked about only covers one single movement or migration. But we have tons of these kind of requests every day to be able to balance the fleet. So this process is designed to handle large-scale migration to solve the conflicts and also being responsible for picking the best destination for the shard movement and kick off the actual move, doing proper retry, cleanup after the migration. So now that we've covered two fundamental pieces of our automation, we can utilize them to do a very interesting thing, which is so-called balancing. to be able to reduce the fleet size by moving different data set around to be able to push the host level utilization to its limit. So like I said, the concept of balancing is essentially to find the right place for the workload so that on each host will achieve the maximum resource utilization. So let me explain how that works using a simplified example here. So for example, if we only have 4 different kinds of workload in Facebook, and then the only bottleneck is on disk space usage, we want to fit into the minimum number of hosts as less as possible. So essentially on the left side, we have 4 different kinds of workload. In total, they are consuming 1 terabyte disk space. And then if all the hosts that are available to us are in 500 gigabyte, theoretically, we only need 2 hosts to be able to serve these 4 different kinds of workload. But let's take an example showing how pool stacking or pool balancing can result into wasting resources. So first, here comes the workload 1, which is 400 gigabyte. There's nowhere to go but to place the workload randomly. And then the replica set 2 comes in. No magic happen here. We put it into host 2. And then the critical step happens here when we're placing the replica set 3. So here we have 3 different choices. Let's assume that we just randomly put it onto host 2, which have 200 gigabytes free slot. And then what will happen here when the 4th workload comes in? It has nowhere to go because the existing 2 hosts essentially couldn't hold such a big workload. And then we'll have to put it onto host 3. And then we end up wasting 1 additional host for serving this 1 terabyte global workload. So that's just a quick illustration to show that how important balances is in order to achieve the maximum host level resource utilization to be able to cut down the number of hosts we will be need for a certain workload. So using the same example to show how to do proper stacking, essentially there's not too much magic there, but to make sure whenever you're trying to put a workload, always find the optimal slot for it based on all the balancing metrics you're using. So here, disk space is the only balancing metric that we're using, but in the practical world, we have different metrics we will take into consideration, like for example, CPU footprint, the memory usage, and even fault tolerance, the failure domain balancing, and also like peak time and non-peak time workload changes. All these metrics coming together and fitting into this mode, we'll be able to find the best slot for each data migration. So coming back to the example that here, apparently the best option for us is to put replica 3 into host 1, and then when the 4th workload comes in, we can put it down to host 2, and then achieve the goal that using minimum number of machines to serve a certain workload. So apart from proper stacking, as I explained, we also have the ability to control the shape of a workload. So here we call it carved shape. So essentially, this new example is showing a slightly different scenario, but surfacing different issues. So right here, we still have 1 terabyte workload in total from 4 different workloads, but now they comes in a slightly different shapes. One is 400 gigabyte, and the rest 3 are 200 gigabyte. Let's see how much trouble this new setups can bring it to us. So the placement for the first 2 workload don't play any difference. We just put it onto 2 existing hosts that we have. And then when the 3rd one comes in, because we want to push the utilization up to a certain limit, we'll put it onto host 2, which again leave us no choice for the workload 4, because the existing slot size won't be big enough to hold the 4th workload. So Essentially, when your workload changes, it might cause some additional overhead to your decision making, so that you weren't able to make the optimal decisions for placing a workload. So what we do here is actually, like I explained, each workload is compromised of a multiple database on an instance. And if we have the ability to move database around, we actually have the control over the shape of a workload. So if we look deep into this workload, they consist of multiple database on each instance. And then we have the ability to move database around to be able to bring the question back to its original form, which we already illustrate in the first example. So by moving one database away from replica set 4 and onto replica set 2, we're back to the same question we've already solved it before originally. And then we now be able to stack all 4 workloads onto 2 hosts to achieve the same balancing goal. So like I've just explained, all these fundamental pieces of the automations enable us to do lots of things across the infrastructure. But on the other hand, they're being heavily developed, and then we want to move fast on these components. So this puts a high demand of a reliable testing infrastructure to allow us to move fast without breaking things. So next, I will hand over to Pradeep to explain how do we test those components.
Thanks, Luke. Yeah, so most of our automation is in Python, and this testing infrastructure is specific to MySQL-related tooling. So the idea of, as Luke mentioned, like we want developers to like really move fast on these, different softwares we have. And all of these components manage very critical pieces of our infrastructure. So if copies doesn't work well, we may have a backlog of broken instances in production. If we don't do balancing properly, we may be utilizing our hardware very poorly. So it is important that these automation tooling work and have like really high availability. We definitely have unit tests, but the problem with unit tests are you kind of mock out all the backend connections. So you're essentially just testing a single function or a single API call. You want to be able to put everything like production, but not technically production, and verify your correctness of your software. So that's why we kind of focused on building like an end-to-end infrastructure, which is fast and which can provide you signals at diff time. Like when you're making the change, you are able to like verify whether your change is going to work or not. So the goals are like, as I mentioned, like you should be, or you would be able to build and canary packages based on the change you're making. Basically, whatever RPMs or tooling you need to build for a specific piece of automation, you should be able to build all that of your single change. And that this is all at runtime. You should be able to provide proper signals at before you land your change or before you commit your change or ship your change. You should be, as I mentioned, you should have like a production-like setup, but in a very isolated environment where you can be comfortable to break things and see why something breaks and fix your change. And yeah, you want to be able to iterate quickly on your change with confidence. So these were like the main fundamental goals which we had in mind when we developed our test infrastructure. So I'm going to explain this with a diagram. So the fundamental backbone of this entire testing infrastructure is we leverage VMs, and VMs have snapshots. So that is the key piece here. And we also have a way to like schedule tests. So you have a diff. Diff is nothing but your change or single commit or a bunch of changes together, and you want to be able to test. So what happens is when you publish a change, so we have a service which would basically check, okay, this is changing copies. Let me build all the packages required for testing the copy process. So it'll kick off that. We have a thrift service, which is basically, you can think of it as, the one where you request test assets, which are MySQL test assets. In this, it is a replica set or an instance or a full host. The testing service will basically look up the metadata which it has and find the right test asset, the virtual test asset in this case, and basically allocate that to the test. All your packages are basically canaried on that test asset, and you do some sort of fault injection testing and everything, and collect all the results and get that result at diff time. Now, what happens after the test? We basically, as I mentioned, use virtual machines. So we have virtual replica sets and virtual instances. Each virtual test asset has an active snapshot and a passive snapshot. So this allows us to quickly, go back to the original working state of the replica set after the test. It is, of course, assume that when you're developing something, nothing works the first time, so you do multiple iterations until you get it working. So you don't want to be, breaking the test asset. So the goal is to how quickly you can have your, test pool back to normal. So that's why we chose to use VMs for this. So we have an idea of what is the working copy of the the virtual asset and the passive copy. And that's what is illustrated on the right-hand side. So when we deallocate, we basically switch the pointer around and reboot the VMs with the passive snapshot, and all the metadata is upgraded. It also has interfaces for developers to reserve test assets individually, like if you want to play around and test specific components under different failure scenarios. So you can hey, reserve me this asset for 12 hours or 24 hours, and I want to play around with it. So all of this test assets have all the prod packages, all the prod-like setup, but it is isolated, so you're not breaking production, but you're just playing around there and basically testing your changes very well. So we have caught a lot of bugs with this, so it has been a very good framework for all our MySQL infra team, and it has helped us with bugs where promotions would have broken if that change would have made it to production, because they were able to get the signal at diff time. They were able to identify, okay, this is the problem and this is how you fix it. Yep, that's about our testing infrastructure in a nutshell. And yep, that's all we had for today. So feel free to ask us any questions. The question is, storage attached to the local machine, is it native flash or is it some sort of network device? So we use native flash on the host. We don't have any network devices for serving. Yes. Someone there? No? Yeah. Yes.
How granular should be your services to actually get a framework like this working? So that you can test it.
So the question is, how granular the services have to be to test in? Yeah, okay, cool. So if you think of the copy service, we have, which is basically be able to replace an instance. So you can test up to that level. So you could you could reserve a replica set and you can break an instance and you can do assertion that will the automation schedule a replacement, and will the replacement complete, and will the replacement be replicating properly. So all these assertions can be performed with this testing framework. Even shard migrations or even individual cases where you do a kill-9 on the master, and your expectation is that when that happens, your automation should detect that the master is down and perform a quick promotion, and you can do all these sort of assertions as well with the testing infrastructure. Does that answer your question? Okay, cool. Okay. So the question is, what is the use of what is MySQL used for at Facebook? It is the backend for Facebook social graph. So whatever you see on Facebook graph is materialized in MySQL. It is also used as a backend for a variety of internal services, like, you can think of it like we have an internal MySQL cloud where people reserve MySQL for holding config data and any metadata about their service and things like that. So Messenger also, right? Yeah. Yeah, Messenger, your messages are like, you can search messages because your messages are somewhere materialized in MySQL. So we have blog posts about these things on code.facebook.com if you're like interested in how this is used. Cool, thanks. Yes? The question is, what is the most used storage engine? Do we know? Yeah. I will let Luke answer that.
So yeah, as Pradeep mentioned, the two major use case of MySQL deployment is the user data and the messengers, and then both two those use cases are using MyRocks. Yeah, RocksDB essentially. So RocksDB itself is just a storage engine, and we use the plugin API in MySQL to plug the RocksDB into a MySQL server so that users can use SQL to talk to the database, and the underlying physical storage format will be RocksDB.
The question is essentially, how do we manage different instances and states, and is it an automated system, or how do we manage that? So that was the question. So all of the things we talked about is all automated. There is code for everything. And we get notified or chirped or paged if something is not working. For example, if we see copies not succeeding in a certain duration of time, we have detections based on that. All the code for this is in Python, and it's basically automation here. Yep.
So when you move from the service directly in discovery from one master to another master, do you use like a router or something like that, or proxy, or how do you handle that?
So there will be no subscription mechanism to talk to the client. Essentially, the client is on their self to figure out the new address, but we will add some hint on the old the source replica set to hint the client to be reconnect onto the new resources. So essentially, once the final flip is done, we'll mark the old database as unusable, and then the client connecting to the old database will start to receiving error. And as a part of the error, they will get a hint to connect to the new instance. Yeah.
So there's no proxy involved, and it's effectively infrastructure which indicates to the client that the master is somewhere else, and it will then basically use that to reach it.
Correct.
You'll never get any rights to an old master.
Correct. Yeah.
Do you ever get shards that are too big, so you need to split even a single shard?
Yes, definitely. So we hit that really often, which also inspires us to develop a new tool to be able to shard the existing data set automatically, so that the user have to do zero changes on the application side, and then the backend storage can be automatically split into multiple shards. But that's still being under developer at the moment. Yeah. So the user have to define the sharding key themselves, and that's the only thing they need to do. And once they've done that, we use similar logic as we've been using for logical migration. Essentially, instead of dump the whole data set, you dump the subset of the data set and then prepare onto different replica sets.
Just a follow-up on what you just said, like the hinting process for the client. Will you have any requests that fail because of that? And if
For example, for the shard migration, the old database will be turning into a read-only mode, and then if you try to perform any DML on top of that, you will receive an error. Yes, and then it's up to the client to decide what to do once you get this error and how to use the hint. But normally, our recommendation is to retry and using the hint from the error message to reconnect to the right properties. One more question. Sorry, could you repeat that?
So regarding a database on an individual server instance, do you still try and capacity plan, say, the next year's worth of growth, or do you end up just accepting you can migrate it?
So the question is, how do we do capacity management for each individual workload, right? So we don't do precise capacity management for individual workload because the diversity of our internal data set is so big that we can actually do it globally. Yeah, and it relies on balancing to reduce the footprint size. So the question is, what's the approximate global storage size, essentially?
Per host.
Per host?
We have different.
Yeah, no matter it's global or per host, we're not allowed to talk about the actual number, unfortunately. Yeah. No, not approved. Sorry about that. But you know that we use direct attached flash, so you kind of get the rough number.
But these days you can get quite a lot of flash on the server if you really want to.
Yeah, right.
You get a lot more than that.
Right. Yeah. Yeah. All right. I guess we're. So we have different storage or stateful service solutions within Facebook. Yeah.
MySQL is one of them.
From the host capacity issue, basically is CPU the real thing? Because obviously with flash, and if you really have, it's quite hard to fully utilize, even if you've got lots of instances running and things, or do you actually hit the capacity of the flash storage as well?
So the question is, what is the bottleneck on a host? So due to the high diversity of a workload, we actually didn't run into any bottleneck. So we were fortunate enough to piece all different kinds of workload together to push the utilization. Yeah. So essentially, the number of disk-heavy workload is pretty much the same amount compared to CPU-intensive workload. And also, now that we're moving into Marox, which gives us more flexibility into trading CPUs for disk space. So we have the knob to actually turn the shape of the workload by migrating to Marox.
So that helps a lot with the resource utilization, that you can reduce that a lot by moving things around to make maximum use of hardware.
Correct, yeah.
Use that for choosing between Myrox and InnoDB as well, or
Can you repeat that?
do you use those characteristics between InnoDB and Myrox as well to balance the load, or it's just because you're moving towards Myrox?
It's a very good point, but we haven't looked into that deep yet.
Because Myrox does use more CPU than InnoDB, doesn't it?
Yes, if you use more aggressive compressions, yeah.
Did you see a decrease in read performance if you migrate to Myrox?
The question is, do we see a regression in read performance by migrating to Marox? So I would say no, because the use case we migrated into Marox is actually suitable for Marox. So we won't move any point, those heavy point queries workloads onto Marox because they fit InnoDB better.
So query profile, you take that into account in which engine you're using as the backend storage for the stuff.
Yes. So at the moment, it's still on a DB-based decision to make that whether this workload should fit into InnoDB or Marox. Okay, cool. Thank you, everyone.
Thanks. It's actually,
So-
we are trying hard, but the problem is it's so